Today I'm going to show you how to solve some log equations without using the calculator. Now in order to do that we need to just run through a couple of log rules that you may or may not have heard before. The first thing is the equivalent log notation. So if you've come across the equation y equals a to the x, you should be familiar that of course x is our log and a is the base. We can write that as log to the base a of y equals x. Now using this equivalent notation, some of you may already know that through laws of indices, anything to the power of 0 is 1. You also should know that anything to the power of 1 is just itself. So using these facts and the equivalents, we can come up with two new log facts. The fact in this one, if we rewrite it in this form, tells us that log to the base a of a is 1. Using this one, we can write that, that one goes with that one, apologies. Using this one, therefore, we can write that log the base a of 1 equals 0, which goes with this one here. And there's another log fact that you will find useful when solving equations, and that is if you've got log to a base of a number that is already to a power, let's say m to the power p, we can write this with the power down the front. This power here can be written down the front, and that is actually equivalent to that. And this is a really useful skill in order to help us to solve some equations. I'm going to clear some space. So I'm going to run through some examples. I've got two examples here. I will be doing a third example after this. Let's have a look at this one. So let's look at 9. 9 can be also written as 3 squared. So I'm going to rewrite that. So log to the base 3 of 3 squared equals x take away 2. Now what I can do is I can use the fact that this power can come down to the front, and it's exactly the same. I'm not changing anything. So I've now got log to the base 3 of 3 equals x minus 2. Well, this here is just equal to 1. So I've actually got 2 times 1 equals x minus 2. And of course 2 times 1 is 2. Now solving for x, I then add the 2 to this side, leaving me with x equals 4 for that one. Let's have a look at this, and it really is a trick of looking about, well, can I get the bases the same? Can I change the bases? Is there anything I can do? And looking at this, I've got a 2 at the front of this whole expression on the left, so I'm going to divide by 2 on both sides, leaving me with log to the base x of 25 equals 4 divided by 2, which is 2. 25 is 5 squared, so I'm going to write that as 5 squared. And I'm now going to bring that 2 to the front. So I've got 2 log x 5 equals 2. Now I can divide by 2 to leave me 1 on the right hand side. And then I'm left with just a log expression, and I can use the equivalent formula to write that as a power. So that can actually be written as x to the power 1 equals 5. 5 itself is 5 to the power 1, so if I look at the powers, I can equate the bases and say therefore x must be equal to 5. I'm just going to clear some space and I'm going to do one more expression. So for this one, I want you to consider what your calculator is able to do. Some calculators are not able to calculate a base other than 10. So I'm just going to rewrite this using our equivalent formula that we came up with. That's equivalent to saying log to the base 2 of 7 equals x. Now, some calculators can't calculate the base 2, so we need another strategy. It's clearly not, we won't be able to get the same base here, so we can't do this in our heads. We're going to have to come up with a new way of doing it. So I come back to this, and the strategy that we use is taking logs to the base 10 of both sides, because it's an equation. Whatever you do to one side, you do to the other. This is actually the same as changing the base, and there is a rule that changes the base. So you can change to a base from 2 to 10. By taking logs of both sides, what happens is I get log to the base 10. You don't normally write the 10, but I will for this example. Log to the base 10 of 2 to the x is equal to log to the base 10 of 7. Now, using the fact that this power can come down to the front, takes me x log, I'm not going to write base 10 anymore, 2 equals log 7. Now rearranging this to make x the subject gives me log to the base 10 of 7 divided by log to the base 10 of 2. This will then be able to place in the calculator because your calculator does work in the base 10 and you can solve it to find what x is. So x comes out at approximately 2.81 to 2 decimal places. Taking logs of both sides is a very, very useful method and used all the time to calculate log equations without being able to use the equivalence formula.